Well, good morning, ladies and gentlemen. I'm a bit different. I'm not an academic. I was operational fisheries scientist and officer in the Environment Agency for 35 years, but I spent most of that time concentrating on estuaries, which is unusual for the Environment Agency. I was based on the tidal Thames. We did a lot of survey work there that led to other things, but I'll touch on that as we go on. But yes, just up top right, Institute of Fisheries Management, that's me. I chair a specialist section of the Institute that looks at estuaries in the marine. Top left is my small consultancy. Bottom right, some of these slides come from my days in the Environment Agency, so I can't not give them their credit. But nice picture there of a juvenile bass. Have you seen those with spots on them like that before? Yeah, exactly, quite a few. But there's a complexing thing here about climate change. Further south from us is Dicentrarchus punctatus, a spotted bass. Now, until bass get to 15 centimetres, some of labrax are spotted as well. So we are probably seeing a slow change where punctatus moves up the coast and we don't necessarily notice the difference. It's happened with the golden grey mullet. They're now spawning off the south coast of England. We didn't realise that until fairly recently, which just simply demonstrates how fast climate change in the water is going on, much faster than on the land. This is part of my history. I was sampling fish in the tidal Thames. We developed something called a multi-method survey process in the late 1980s with a beam trawl, a big seine net, and key, a biologist kick sample net, which sounds very small, doesn't it? But that's taking 7mm jobs that you're not going to find in the other method. Never use a single method, always use a multiple method. So these little flounder at 8 to 9mm, at the time we took them, scientific papers were saying flounder do not come into British estuaries till they get to 2 centimetres. That's an artifact of how they're being caught, not what technique you're using to find them. But the one in the middle, if you haven't seen a bass that small, that's classic. That's just prescalation at about 15mm. And you get this very pronounced line on the top surface and the bottom surface before the scales form. But a lot of people don't know that's a bass. When I first saw one about 1987, I sent it straight to CFAT, to the late Graham Pickett, who said you'd be surprised to know, Steve, that's a juvenile bass before it scales up. Why did you find it at Chelsea, a long way up the tidal Thames? Now, that's another one of the myths. At the time, people were saying is the young of the year can't go into pure fresh water. And we caught this one and some others with him. He was 3 miles into fresh water. The species can always surprise us with what they're capable of. That's one of the first things I should say with that multiple method approach, I ended up leading for the Environment Agency and then for the whole of the UK in a project for Water Framework Directive describing how do we sample fish in estuaries. So we were now sampling fish in estuaries all over England and Wales and further afield as well. A generic factor that comes out of that is they're full of small fish, like juvenile bass. And even from that point, we were talking to marine fishermen and regulators and saying, isn't it a bit silly to be allowing mass trawling deep into estuaries when you've got that density of fish present? So if you've got the data, you can make a difference with it. And through our institute today, we have a position statement on estuaries, which I'm pleased to say a lot of IFCAs have picked up on in recent bylaw changes. So in most of our estuaries, you can't go trawling deep into the estuary because of the damage you're doing. And to try and link to something our keynote speaker said, if you can get everybody on board with the data, you don't have an enforcement problem because they're all bought into the process. All the commercial fishermen, all the anglers, all the regulators know about it. Anyway, by 2003, I've gone a bit sideways into salt marshes and what we now call managed realignments. And sitting in the audience is an old friend of mine who did our PhD on this site, Lena Fonseca. That's a sloping field with 5 holes knocked at the bottom of it. Why? Because we're losing such habitats through coastal squeeze. What we now know, we've got to do this more because of sea level changes, sea level rises and storm surges. So in the mid-noughties, we did a whole series of studies on this that fed quickly into something the French had already said in Mont-Saint-Michel Bay, that the salt marshes are the prime nursery grounds, undoubtedly. That's where the bass want to go. They want to go deep into the salt marshes to feed heavily on just a few days in the monthly cycle of the tides that they can do that. That's where they want to feed. And Leila's work showed very clearly that these bass are coming in and the very small ones go as far into the salt marsh as they can. When they get a bit bigger, they come a bit, they don't bother going quite as far and they're feeding on something a bit bigger. It's very structured. Ben Green, a few years later, showed on these sites with radioisotopes that young of the year bass fry are very faithful to precisely the same piece of marsh for the whole of the first summer. Now that's interesting if you're looking at creating new sites. And just to bring a statistic in there, salt marsh we now know is very important. We didn't know it beforehand. We've lost 80% of the salt marshes in Western Europe. We've lost 85% of the seagrass beds, which are just underneath them in the tide. We've lost most of the kelp forests. Historically, what you would have had with all small fish species, including the bass, is to spend the whole intertidal cycle sitting in the vegetation somewhere, going from the kelp through the seagrass to the salt marsh and back again. They don't get predated on. They've got lots of food. They've got lots of cover. It's very warm. Why wouldn't you go there? But something I forgot to say, they're not swimming. Most small fish in estuaries are using the tides to migrate. They use the tide when it's going up to get onto the surface and drift for maybe 12 miles. Where the Thames, it's 13 kilometres. At high water, they just get on the bottom, get in the sides, hide while the ebb tide goes out, and then they do it again on the next flood. Do the same thing in salt marshes. They don't want to bother to swim. It takes energy. If you're a 50mm bass fry, you just want to drift in on the tides, go as far as you can, feed as long as you can, and get out. While you're in there, you have a competitive advantage because it's warm, there's lots of food. Now, these things sound quite logical, but it's taken a long time to work some of these processes out. Salinity and temperature and seasonal habits, of course, play a big part in that. In more recent years, I've been doing a lot of citizen science. Here's one on the Hazelwood marshes in the Old Estuary with both fixed fight nets and seine nets. They're volunteers from the Suffolk Wildlife Trust, pick up lots of data. Now, this work is really starting to pick up now. Lots and lots of people want to get involved in this sort of work. Bird watchers, anglers, all sorts of people. So through our institute, we're now training groups of volunteers to go and do these basic fish surveys. But then we spoke to people like Kieran. He says, Steve, that's great. We've got big holes in the data, places that nobody's ever been. You're filling some of those. When those volunteers aren't with us, they're going around enthusing about this or talking to other people about it. There are social benefits that come out of this as well as the data. There's two of my prime citizen scientists. That's on the Otter Estuary last year. And in that little V-shaped plastic container there of perspex, measuring rule, we don't have to handle the fish, just pop them in there and measure it and take a good photograph on its side as well. Those are the methods we tend to be using. Again, that's on the otter. And again, this is where people have to understand how fish are using the site. And I show it because the picture on the right, tiny little sea bass or common goby or thin-lipped grey mullet are coming in on the head of the tide. As soon as it comes in, they're right behind it. They come screaming up these channels. As the water rises, they go right over the top of my winged fight net, deep into the salt marsh. As soon as the tide changes, they get on the bottom and find the drainage channel out. So where you put that and where its wings are is critical to how many of those fish you're going to catch. But you need to understand fish ecology to do it. That's another one upon the tees, seine netting. And this is another thing about climate change. This is a site we've done 3 years running in recent years. 4 years ago, nobody had any evidence that the thin-lipped grey mullet was spawning that far up in the northeast. 2021, we found 0+ fish. Now we found 3 different size classes. Same thing with the sand smelt. They're both known to be warm water species. They're creeping up the northeast coast, but nobody was studying these things till a group of citizen scientists started looking at it. I'll just show that one, the one in the middle, very fine mesh net, just set out. You can hold it in a V shape or just set it like that. But that's the one that displays, you put that out when it's dry. As the tide comes in, within 10 minutes of the tide, and it's still only about that deep, just lift it. You might have 500 common gobies, some thin-lipped grey mullets, some sea bass in there. They want to get in there as soon as they possibly can. That's that sample tray that happens not to be bass, but you can see how it works there. Again, when we're on site, this is to try and make it accessible to citizen scientists. We're not using expensive gear. We can measure salinity with hydrometers and refractometers and temperature. So it's good data, but we're not. We're keeping it cheap. We identify fish. Guides like this on the right are really good, but they're all large fish taken from power station cooling water screens. Where the fry, we've worked with both Sussex IFCA and ZSL to create this sort of thing. A5, fully waterproof. Again, most people haven't seen a bass that bit small before, but you can take this in the field and it doesn't get damaged. That's just a historical photograph or plan of where I've been involved in salt marshes and estuaries looking at sea bass in the past. All the red is actually Environment Agency data up to 2015. But on top of that, these green ones and blue ones are some of the salt marsh work we've been doing with citizen scientists over the last few years. There's some of our reports. If anybody's interested, I've got several here. If you'd like to look at them, I can, discuss that with you. And that's my final slide, but this ties in with something that Anna was saying. We can now demonstrate that salt marshes are really important habitats for sea bass fry. We are creating new sites all the time to counter sea level rise and storm surge. Unfortunately, they're done by engineers. Any engineers present? Engineers think in nice straight mathematical lines. So that's what they design. That is nothing like that. The fish find that very hard to migrate through. You imagine you're trying to drift in gently with the drifting tide into a salt marsh and you face that instead. Very fast flows, very turbulent water exchange. It's not what they like. So I'm in the process at the moment with some other authors. We're developing a whole series of notes to say to the engineers at a conference next week, sorry, later this week, Rememory, which is a government process with lots of regulators to look at large-scale habitat recreation. Think more like a fish in your design, and we can get much bigger fish production. Think about what Anna said about 1% survival of this early life stages. It's because we haven't got the sufficient habitat. We've lost 80% of these sort of habitats across Western Europe. We're now having to put them back. If we get the design right, we can have massive implications for both fish, carbon sequestration, nutrient stripping, and all sorts of things. I'm going to finish with one last plug. I can't resist this. In semi-retirement, this is my other particular passion. If as a sea angler you see one of those, we hear of a commercial fisherman at sea taking one, tell somebody, tell me, tell somebody. And by the way, this isn't the stuff you see in the angling press. They're all a joke. They're all aliens that shouldn't be there. This is Acropens estuario. It's coming back to this country slowly from French and German restocking in their rivers. But they're great migrants. They can do 1,000 kilometers, no problem at all. They're now in Start Bay and Lyme Bay in particular in low numbers, and eventually they'll start going up our rivers. So if you see them, please tell somebody. Please put it back if you catch one. Thank you.